So for example here, we want to determine, say we are given, say theta GST on the 0 hours, 0 minute, and 0 seconds on first 1992. That's the data I have from our textbook. So this one, this angle, so basically theta ST on the specific moment, and that one is, what is that? Okay, so hopefully here won't confuse you about the description of the information. So this one basically is saying this is on our Earth time, we count on Happy New Year, right? That is the beginning of the midnight, and to that moment I believe the kind of the firework, a lot of things, good things going on there. And this number is basically indicating you convert into angle. And that, if you convert this into angle, basically that tell you what this angle is in that specific moment. Okay? So that's the meaning of the things. And here's I'm kind of mix using the two different formats, the same format for different things. So for this case, basically here I want you to let you know that is again. Let me draw this one here. So this is Greenwich. So at this moment, so here we have the angle here, theta GST, and the 0 hours and 0 minute and 0 seconds and 1/1, 1992, and that one basically can be converted into that one. So that is this angle. So this is the angle. Okay, so that is the angle indicated by this one. So now we want to find is theta GST. The same thing, we want to know where the Greenwich longitude is in space. The launch time, minute, August 20. 1992. So about 8 months later on this specific time, we want to know where the longitude line, or sometimes called the Mediterranean. Okay, that basically indicates on the line. We want to know what that angle is on that specific day. And from here you can see every day the Earth kind of rotating, make 360 degrees. So from here, basically, we simply is to calculate how many terms the Earth has been made from day one to this moment, and then we simply multiply that terms with 360 degrees, then add it up to this number, we got the answer. That is the concept. Okay? So basically, that is this. So let me say theta GST will be equal to, at any moment, will be theta GST at the, say, I would say, say, let me say, how about let me give a notation, say this is a reference, 0. Okay, so that's our reference. Plus delta t. the time we elapse and multiply with, for the time we measure, this is measured on the Earth's time. Actually, for each day we measure Earth is have the rotations, so that is multiplied with 1 point, that magic number, 273 and 9093. This is our Earth time. So that is the time system we measure by living on the Earth. But for each day, we have this kind of rotation converted into the sidereal time. Okay, so that is the tricky part, and many times the people kind of prone to forget the kind of the conversions. Keep this in mind. So right now, for this case, calculation is easy. Simply we find out what is the time elapsed from the beginning to where we want to calculate. Okay, so now we see this exercise will be focusing on how to determine data peak. So we have a table, and otherwise you can calculate. So this is from our textbook, but you can make your own tables. So, say this is a date, 1, and elapsed days. Okay, so say we're starting from the January 1st. So at that day, we elapsed is 0, and then we're starting from January 31st, and elapsed date is 30, and then February 28, then elapsed day is 58, and if that is a leap year, then that could be 31st. And that would be 89. If that year is a leap year, so we have one more day in February, so that would be 90. Okay, so you can accumulate this one. Basically, this is a table available from our textbook. So let me continue, skip out the few, and then say go to say July 31st. And go to July 31st, that is the 211 days, or otherwise in leap day is 212 days. Okay, and that information we can base upon. So right now, our point is on October 20th. So October 20th, that actually is 20 more days beyond this, right? So this is on the July 31st. Right now, we are on October 20th. So I pick up this number as my reference. Otherwise, you can calculate it from the beginning. That's okay. Okay, so for 1992, and that is a leap year. So keep that in mind. So I need to pick out is this number. Okay, so October 20th, 1992, and the time is 12 hours and 14.96 minutes. So right now I'm going to convert how to calculate delta T. So right now, from day one to July 31st, how many days? 212 days passed. And now we keep counting to 20 more days to get this one, so 20 more days. So that's the number of the days. And on that day, we have that much more hours be passed. So here the calculation is we added up 12 more hours, and that hours per Earth time, that is the half day. Divided by 24, that's the number of the portion of the day. And then we have minutes, so here is 14.97 minutes. So how much how many minutes in a day? 1440. If you like, you can divide by 24 hours, and each hour has 60 minutes, the same thing here. So this number will give us how many portions of the days being passed. So this one is 232.510 201,388 Earth days being passed from the beginning of this reference point. So this is our delta T. Got it? Okay. So once we have a delta T, I simply multiply, because that's the Earth day, Earth time. So multiply with this scaling factor, convert it into the sidereal time. Okay? So therefore, so delta T multiply with 1.002739093. For this calculation, you better keep as long as detailed as possible. Okay, and then to the very final step, you can always truncate or approximate. So for this one, basically that one is 233.1467931 sidereal days. And this is the real number of the rotations the Earth being rotated from day 1, from day 0 to there. And this is the term. Sidereal day, that is the number of the term, 360. That is the terms the aliens see from space. Good? Okay, good. So this one, basically, if you convert it, we can continue. I want to convert it into days, hours, minutes, and seconds. So they basically, these are 233 days, right? And then the portion, here is my side calculations. So 0.1467931, that is the number of the days. I'll multiply with 24 hours. So that will give us the hours, right? Anyone has any calculators can read that for us? I want to go through this one in detail. So right now we have this portion. So that means in your calculation, you simply, it's right now in your punch calculation, you have 233. How about this? You simply, in your calculator, you minus 233, then you get this number. Okay, so once you operate this calculation, you have this number. You minus 233, you have this number left. Then you simply multiply with 1.002739009. No, sorry. This is the number of the days. I simply multiply with 24. So that's a portion of the day. Multiply 24. How much? Anyone can read that for me?
3.5.
3.5.
230,344.
Okay. So that is that's been hours. Okay. So that is 3 hours. And now I want to keep continuing. So this one you simply minus 3. So you minus 3 from your reading is 230,344. You don't need to retype. Okay, simply continue. You minus 3. And this one right now is in the hours, right? In the portion of hours, I want to convert into minutes. So you simply multiply with 6, and right now it's in minutes. How much? Can you read that for me?
31.382064.
64, something like this.
Yeah, 382064, but yeah.
So right now it's a minute. So right now we have 31 minutes. And then keep continue. So you minus this one by 31, subtract by 31. So you have 0.38264. Right now is a portion of the minute. You multiply with 60, get into seconds. How many?
22. 22.92384.
Good enough. So that is 22.923 seconds. Okay, so right now I converted into here. Why? Because the GST we are given, and the reference we are given is in this. So therefore, from here we can say, so therefore GST on 0H, no, on the 12 hours, 14.69 minutes, A20, 1992, basically is, basically we put into this one, what is this number? That one is 6 hours, 39 minutes, and 374863 seconds. So that is this number. And what is number? That one is this one. 233 day, 3 hours, 31 minutes, and 0.2923 seconds. So we simply add it up. Okay, good. The first one is this one, which right now I multiply using this formula. So first number is this one. That one is given. I simply copy to here. Okay. The second one is we just been calculated. So this one will give us is if you implement. So basically this one will be more than 60 minutes. No, this added up together with more than 60 seconds. So more than 60 seconds, you simply convert 1 more minute into here, kind of convert it. Okay, so this one would be equal to 233 day and 10 hours, 11 minutes. And then this one will be 4078. Sorry, and this is my answer. My answer has a little discrepancies on here. So whatever the numbers, here is my answer. So you simply add it up, okay? So for this one, this is the sidereal day. And right now, sidereal day, we kind of convert it into the day, hours, minute. But you can convert into angle, and angle is more valuable for our calculation. So again, for each day, for 1 day, in terms of sidereal time, is 360 degrees. And again, sidereal time. And 1 hour is 15 degrees, and 1 minute is 1/4 degrees, and etc. So basically, you can convert in this angle. That would be 84032.7517 degrees, and 1 turn is 360 degrees. So you can modulate by 360. So that one you modulate mod by 360. So that one actually is 152.7517 degrees. So we spend so much time, then we determine that specific day on August 20th. We know the angle of the Greenwich, that angle here. So here on that day, so here I would say on this day, August 20, 1992, on that specific time, 12 hours, 14.69 minutes. So this angle will be equal to 152.7517 degrees. We good? So again, let me let you finish the writing, and let me go over one more time. Again, in this calculation, we have involved 2 different time systems. One time system is the Earth. That means our calendar. Okay, our calendar, that is the Earth time. So we simply look at the Earth time and how many days on the Earth time. then we multiply with this number. That number, because here we do the transformation between the Earth or solar time to the sidereal time, and that is the number here. So basically, this one here, the theta GST, that has the unit of the sidereal time, and sidereal time actually is the what being observed by an observer outside the Earth. Okay. So right now in this calculation we've been calculating is based upon the sidereal time system. On the sidereal time system, we can always convert in using this angle about the angle. So here that is the one we calculated about 152. Good. So let me ask you, at this moment, what is the local sidereal time of Fairbanks? Anyone has a phone can look up what is the longitude of Fairbanks? Can anyone look up for me? How much? Minus
147.
147, and I want more precise, a little bit more precise. Yeah.
0.7164.
164.
0.7164.
147.164. Right?
0.7164.
Good.
No.
Point.
0.7164.
Thank you.
No worries.
So that is the west, right?
Mm-hmm.
So basically that is minus 1.7164 minus. Okay. So at that specific moment, the theta LST at Fairbanks, and on that specific moment, okay, so basically that would be this number, 152 theta GST plus lambda, so that is 152.7517 and minus 147.7164. So that one, do the subtraction, that will be 5 degrees, 0.03, 3151 degrees. Got it? Okay, so what is the theta we can use? So that is the theta if, say, if we have a radar, yes, in GI, and then we have a vibration. This is the theta that you could use in the D matrix. If you remember our previous, you can turn over your lecture notes in previous sections. When we do the calculation of the D matrix, they have one parameter about theta. Think about what is the meaning of that theta. That theta actually is the local sidereal time. So here, this will be the section as in preparation for determining the orbital element. Okay, and that is the theta. And actually, determining theta is not very trivial. It's not trivial at all. Okay, and I can tell you definitely in test 2, this should have at least one question about this. Okay, so be ready. Okay, so that reason, and probably today or tomorrow we can go back to and begin to work on the second portions of the homework, just about this one. I think there's 2 questions there. Okay.